Okay, this is my Sharp microwave. It was produced in 2000, I believe, and I picked it up probably in 2005, 2006, somewhere in there. I remember it came in out of warranty. I think it had a bad fan motor, and the customer did not want it repaired, so I went ahead and repaired it. And I've been using this thing for probably like 15, 16 years at this point, and it's been working perfectly. But just the other day, I noticed the light, I thought it was dimmer than it should be. And then this morning, I got up a little bit early with the wife, and she noticed that the time display is blinking, just a constant blink. So I've got the service manual pulled up here on my laptop, and I'm going to scroll down here until I get to the schematic of the power supply board, and I'll show you what I suspect is the problem. Okay, let me zoom in on that just a little bit to make it easier to see for you playing along at home. I suspect C1, which is a 1000 microfarad 25 volt capacitor, is going to be the problem because that's what takes the incoming AC voltage through this transformer, through a bridge rectifier, and then that's filtered and it's called VR. Now what's interesting is the clock does not lose time when it does this. So I hope that's all it is. I hope there's not something else strange going on. Because if you look here, C5 is actually labeled VR right there. And it goes directly to the diodes right there. And then C6, which I believe is going to be ground. Almost looks like they've got the diodes labeled backwards. What? Oh, look at that. Ground is the positive and VR is the negative output. Okay, that makes sense now. And so it goes through this, is that a 560 ohm resistor, and then through the Zener diode regulator assortment, and it actually feeds into the microprocessor right there. Oh, that's a reset command. Oh, interesting. Am I on the right line? Yes, that is labeled reset. So where does it get? There's what's labeled as VC, and oh, I lost it. No, VSS right there. So I don't know if this 220 at 10 might be a problem. That 220 at 10 is actually on the door itself because this is a oddly constructed microwave. As you can tell, it's a very odd shape unit, and everything's underneath the unit, which is weird because it's a very narrow microwave. Anyhow, let's go ahead and pop the cover off of it, and we'll see if we can find this C1 capacitor and see what it has to say. Okay, hopefully you can see that in there. There is the board that is the power supply. I do currently have the unit disconnected, and as you can see, everything sits underneath the cavity on this unit. There's the high voltage transformer. There is the I believe that's the fan up there in the front, and then over here on this side might be kind of hard to see, but the magnetron lives under right here. The magnetron lives underneath the cavity. Very strange configuration. Yeah, there's the bearing for the fan right there. That's what I had to replace previously. And like I said, it's been like 15 plus years ago. So let's go ahead and get this board up and out of here. It looks like it shouldn't be too much work, just a couple of screws. There's the cable that runs up through the door to the display because the keypad and the display are actually part of the door, and it's a pretty good sized microwave, and it just has always worked very well for us. So let's go ahead, get the right bit in here, and we'll go ahead and zip these out. Maybe if I can get from a weird angle here. Oh, they're coming. Let me get a different screwdriver. One moment. Okay, we'll see if I can get it with this long guy right here. I think there's only 2 screws that are holding this down. So I'm hoping it just has some tabs. Let's go ahead and unplug the keyboard. And I'll try to flip this guy up and see what happens. A little bit of hair. Let me go grab the ESR meter and we'll check that capacitor right there. Okay, I've got the ESR meter. Let's power it up. And hopefully I can prop it somewhere where you guys might actually be able to see it. Let's see if I can see. Oh, you can see the numbers there. That'll be fine. Okay, let's go ahead and check the ESR of that 1000 microfarad cap. So I'm going to do just a lead check, 0.00. Hopefully you can see it. And wow, 0.04. That is actually excellent. That is not what I expected to find. I thought for sure it'd be like 2 or 3 ohms. And I believe that is the only capacitor on this board. So that's not the answer I was looking for. Well, I guess I got to get the door open at this point and check. I think it was a 220 microfarad capacitor inside the door board that drives those LEDs. Maybe I've just got a failing LED, if nothing else. All right, let me get the door open and we'll find out where we go from there. One moment. Okay, well, as you can see, I do have the door disassembled from the microwave. And I'm trying to do this all out here where it lives. Wasn't too terribly bad. There's a little plastic microwave guard that goes around it. Just got to snap that off. I'm not sure what's in there. If somebody knows, let me know. Some kind of metal, plastic, something. And then hopefully we can get this open quite easily. Oh, what's interesting, there's 2 capacitors on this board. Now, I thought that the manual only showed 1. That's very interesting. So what are the values? Let me find my flashlight. Oh, there it is, right in front of my face. So I do see a 10 at 35, and then there is the 220 at 10. So let's go ahead and ESR both of those capacitors and see what they have to say. Okay, hopefully you can see that. Zero it out. And hopefully I don't get in the way. So here is the 10. I expect to see 4 or 5 ohms if a cap is good. 3.6. And here is the 220. Oh, 2.9. That's bad. I would like to see probably between 1/4 and 1/2 of an ohm on that capacitor. In fact, let me go grab a new one right now. 220 at 10. One moment. Okay, I do have a couple of new caps right here. I do have a 220 at 25. I didn't have a 220 at 10. I'm just going to change this one because I am here. And this is going to be a 10 at 50 that's going back in instead of a 10 at 35. I don't like going too much over in the voltage. The capacitor does not form correctly. Let's say you have a circuit that's only got 10 volts on it and you put a 450 volt capacitor in there. Yeah, it's much larger physically, but because of the basically the plate separation, it does not form correctly with only 10 volts on it, as opposed to, you know, a 450 volt cap would have 300 to 400 volts on it if it's designed correctly. Now I've got to be kind of careful here, and I am working on the top of a stereo because my workbench is a mess and I did not expect to be doing this today. And why won't you come out? Now, I do have to be fairly careful. There we go. Because the LCD ribbon cable does not disconnect from the board. So let's go ahead and just unsolder these guys. I've got the solder sucker warmed up and ready to go. Remembering that the big capacitor goes here. I did verify silk screening is correct. Hopefully there's enough physical space. I think there's going to be. And that's backwards. Ding dong. Helps if you put it in the right way. Make sure you get your positives and your minuses in the right holes. Otherwise, the capacitors get very mad if you don't. Okay, capacitors have been replaced. Look at those LEDs. Those things have been running for probably 20 plus years. Make sure we are oriented correctly. Negatives are facing down. And everything else looks good. I'm just amazed at the... I thought that was going to be an incandescent lamp. Let's take a zoomed in look. One moment. So there's a nice zoomed in view of the LEDs. And it certainly looks like there's a little black dot in front of every single one from being on non-stop for 20 plus years. You can definitely see where the light originates. I'm surprised there are surface mount LEDs on a unit of this age. But nevertheless, let's go ahead and get this thing thrown back together. There we go, as a close-up view, just in case anyone needs any part numbers of resistors or whatnot. And I did have a partial schematic posted there. And then not much to see on this side. There's the crystal oscillator CF1. I guess I should look. Those are notorious for breaking solder connections. Oh, but those look absolutely perfect. So let's throw this back in and see what's going to happen. One moment. So I thought I'd go ahead and ESR that capacitor. So there is the leads zeroed out. Just for the heck of it, we'll take the little 10 at the same time. 1.4, better than it was. And then 0.29, which is kind of what I expected to see, about a quarter ohm instead of, what was the other one? 2.5, 3 ohms? Okay, so it looks like all I need to do is throw the little cover back on it and then remount it. And I may go ahead and change that 1000 microfarad on the main board just to be safe, even though it did ESR okay. I'm not sure. We'll cross that bridge when we get to it. I've got a lot of stuff going on today. What's interesting, they used machine thread screws. Oh wait, no, that's not the right one. My bad. Those are the two that hold down the main circuit board in the big part of the microwave. That's better. These are plastic thread screws. Okay, let me get this thing thrown back together. One moment. And I did go ahead and, yeah, we're going to change that main filter cap just because we are here. Why not? And it just fell out. Wonderful. All right. Well, we know that the negative did face down on it. I do have a brand new, this is a Nichicon 1000 at 25. All these caps going in are 105 degrees Celsius caps. And as you can see, that one is an 85. All right, just gotta, it's very tight quarters in here. So positive goes there, negative goes there. Okay. Let me get that soldered into place. And I thought I brought my solder out here, but I guess I did not. One moment. Okay, got some solder. We're just going to use the solder sucker to solder it in. I'm sorry about the less than ideal lighting conditions here. There we go. There, it's starting to take. I always like to try to bend these lathes straight so there's no extra torque on the part. There we go. Okay, happy with that. Old cap out. Is Elna capacitor. Those weren't bad. They're not like Suscons or anything, but they were not super bad capacitors at all. Well, let's get this board back in it, and then we will go ahead and get the door attached, and we'll give it a test. So, once again, one moment. Okay, well, moment of truth. Let's plug this thing in and see what it wants to do. And I think it's still screwed up. Let's set the clock. It's currently 8:10. So clear, clock, 810 clock. And the freaking thing is still blinking. But does it actually work? Let me get a little cup of water. So it actually does work. It's just the display blinks. No, that's not the camera shutter. It's actually blinking. Well, I guess I'm going to have to devote some more time to this. Unfortunately, right now is not the time. So I'm just going to throw this back together. We'll keep using it as is. Hopefully it keeps working. And maybe we just got a failing LED. Wouldn't surprise me. These things, like I said, are 24 years old since 2000. So maybe we just got some bad LEDs. Maybe that's the whole problem. Anyhow, we'll follow this up on part 2 when time allows. Everyone, thank you for watching. I really hope you have a great day. Bye-bye.
I do love those flowers, so if you ever pull...
Okay, first camera recording. Okay, this will be the intro take. Second camera recording, audio sync. Check, check, check. 1, 2, 3. Check, check, check. Okay, segment 2, the top has been removed. Audio check, 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 check. Okay, here we go. Segment 3, the door.
Is the camera on?
Well, not yet.
Okay, stop.
Okay, hang on. I have the audio camera on, but not the video camera. So let me go pause it. Okay, here we go. The reassembly stage. Audio sync. 1, 2, 3. Okay, here we go. Changing the main filter capacitor. Okay, here we go. Changing the main filter capacitor. Check, check, check. 1, 2, 3. Okay, here we go. Recording the outro. Obviously, part 1. Check, check, check. 1, 2, 3. Check, check, check. Audio sync.